Welcome, everybody. My name is Chris Winslow. I'm the director of the Ohio Sea Grant Program, also director of Ohio State University's Stone Laboratory, and very grateful to be also the executive director of LEARN, so the Lake Erie and Aquatic Research Network. This is the team that is undertaking the Wetland Monitoring Program from the DNR, funded, of course, by the governor's H2Ohio initiative. And I'm actually going to quickly turn over the event to Dr. Lauren Kinsman-Costello, who is the lead researcher for our Wetland Monitoring Program. But I will be here at the end of the presentations to facilitate the Q&A. I hope you enjoy the presentations. I look forward to the questions. Lauren, all yours.
Great. Thank you so much, Chris. And thanks to all of you for logging in today for our annual H2Ohio Wetland Monitoring Program update. I am Lauren Kinsman-Costello. I'm an associate professor at Kent State University, and I get to lead this awesome group of researchers and coordinate with all of our amazing partners on the H2Ohio Wetland Monitoring Program. So most of the people logging in today are probably already well aware of the governor's H2Ohio initiative. And the part that the Ohio Department of Natural Resources is playing in implementing this pretty ambitious plan to improve water quality in the state of Ohio and Lake Erie and elsewhere because of everything downstream of what's in Ohio. To date, the ODNR has implemented over 170 wetland restoration projects throughout the state of Ohio. You can see this map here showing where all of the dots of completed restoration and restoration projects that are in progress. And I guarantee you this map is already out of date, even though we got it just a couple of weeks ago. So the state has made a really incredible investment in wetlands as natural infrastructure to improve water quality. And it's one of many different practices that are being invested in throughout the state, especially to limit phosphorus loads into places like the western basin of Lake Erie, where they drive harmful algal blooms. But the information and our understanding of how wetlands actually remove nutrients is limited. And we don't yet have enough information to directly assess the cost effectiveness of these different investments in wetland restoration as in comparison to the other parts, the other practices that are being implemented as part of H2Ohio. And more importantly, we don't fully know how to optimally manage, especially novel, newly built restored wetlands to maximize water quality improvement and also provide many of the co-benefits that wetlands can provide, things like habitat and carbon sequestration and climate change mitigations. So these unknowns are really well known to the state and our agency partners at the Ohio Department of Natural Resources. And because of that, they sought out a group of scientists that are all members of the Lake Erie and Aquatic Research Network, and we call ourselves the Wetlands and Water Quality Research Group, to design and implement a wetland monitoring program to actually assess what is the effectiveness of this large investment in wetland infrastructure and how can we optimize, how can policymakers and decision makers optimize use of wetlands for water quality improvement in Ohio. So that's our three main goals of the H2Ohio Wetland Monitoring Program are to directly assess the nutrient removal of specific H2Ohio wetland projects, and through the information that we generate through that monitoring, evaluate generally the effectiveness of the H2Ohio Wetland Implementation Program, and more importantly, guide its future implementation and inform the design and wetland and management of future wetland projects and the ongoing management of existing wetland projects. We operate on a set of core guiding principles. Firstly, we are a science-based program. It's run and implemented by university scientists throughout the state of Ohio and teams of researchers. We're committed to creating credible data that's quality controlled and really committed to an open science framework, which means that we've invested a lot of energy in identifying places like the Open Science Framework as a place to post many of our protocols and products. And ultimately, we will be sharing our data products for use by the public and other researchers. And at the end of this presentation, you're going to get some links to some places where we're starting to share some of our products right now. We view ourselves as not only a community of researchers among ourselves, we're a pretty large community at this point. Something like 30 individuals are directly contributing to the monitoring program, but we also interact regularly with lots of wetland professionals, ODNR and other agency partners and conservation partners. And by virtue of leaning into our existence as a community and really listening and communicating with all of these community members, the monitoring program benefits from the diverse perspectives that all of these different individuals play. And we structure our program to allow for that kind of communication. We learn by doing. In a perfect world, we would have had 10 years before any of these wetlands were restored to design the optimal monitoring framework, perfect statistical design to just fully answer that question. But we knew that that was never going to happen and the wetlands weren't going to wait for us. So we started collecting data early on in our monitoring program. We've made some mistakes and we're going to continue to make mistakes, but every year we learn more and more while we're continuing to collect data and build a foundation for long-term monitoring. Because we know that every ecosystem is dynamic. Every year it's dynamic in Ohio. You think about one winter to the next, one spring to the next. Every decision we make is sowing the seeds and building a foundation for long-term monitoring, because we know that no single year, no 2 years of data or information is going to give us a full assessment of how these brand newly built, newly restored wetlands are going to function as dynamic ecosystems. And finally, really importantly, our monitoring decisions are based on, as directly as possible, measuring the nutrient removal functions that wetlands are providing. So we're not based wholly on structural indices of nutrient removal like wetland size or any kind of broad scale habitat type classification. We're doing our best to reveal some of those invisible nutrient removal processes through the kinds of sampling and data analysis that we are implementing and planning. This year's public webinar is really exciting. I think it's our third one, which is really crazy to me. First off, our program coordinator, Olivia Schlegel, is going to provide a brief reminder overview of our program structure and some exciting highlights of what we accomplished just in the past year. And then we're going to share some exciting preliminary data through a case study on a specific flow-through wetland. And Stephen Jackman from Wright State University, who leads field sampling and lab work for all of the southern Ohio, H2Ohio wetlands that we monitor, is going to present that. And then we'll have some closing remarks and hopefully some time at the end for questions and answers. So there's a question and answer, a Q&A feature in the webinar. Please enter your questions there. We'll be compiling them during the webinar. We won't get to all of them, but Chris will select some at the end to ask our presenters. And with that, I'm going to turn it over to Olivia.
Thanks, Lauren. I'm having a little trouble starting my video. There we go. My name's Olivia Schlegel. I'm the research coordinator for the H2Ohio Wetland Monitoring Program. I'm really humbled and honored to be able to share some highlights from this year and a reminder of our program function. When folks ask me about my job or about this program, the three biggest things I like to highlight are: number one, this program succeeds because we've invested in people and people invest in this program. And so a lesson we learned early on as the program was built was we need full-time and part-time technical staff to ensure consistent sampling and institutional transfer of knowledge, both in between institutions and across time. As Lauren mentioned, we're deeply committed to data management structures and workflows that both set us up for short-term success in terms of answering the urgent questions about the nutrient function of these wetlands. But I think it's really important to name a lesson from this year, or stories I've heard from this year, are the long-term value of these data sets we're setting up. We've talked with watershed modelers who are so excited that we're filling gaps in important data that will help constrain their models over time. We talked with restoration professionals who say, oh, we've always wanted to be able to monitor, we just didn't have the capacity. So again, this investment in data management structures up front is an investment that is worth the time for this long-term value. Finally, one of the biggest strengths of our program I always like to highlight when I brag about our program a lot is the direct interaction of agency professionals, restoration managers, and university researchers. Lauren already detailed that the dialogue and communication across these different roles is really important. I'll kind of move through a reminder of how we have structured our program. If you want more information about the history and foundation and other elements of our program, I encourage you to watch one of the previous year's webinars where Lauren does a really good job explaining our framework. I'm going to go kind of quickly through it. Then I'll make sure to highlight the people of our crews and the work they do on the ground before I turn it over to Stephen for the case study. So our program is structured in a series of monitoring phases. Because these are young wetlands, we had the opportunity to get some pre-construction information, including attributes like design plan, management goals, wetland size, etc. And we have a little bit of data from pre-construction at a lot of these sites. It's important to remind ourselves that we're not really looking at a before and after picture of these wetlands, but understanding the history of these sites will help us interpret kind of the present day function of many of them. Post-construction characterization looks very similar to pre-construction characterization. It includes walkthroughs through the site with partners, continued kind of look at restoration approach and other attributes. And this phase is really exciting to me because it's where we start to see if there's a discrepancy between maybe a design and something that had to change during construction. And we're really careful to document those so we're getting the most accurate picture of these wetlands. We have to understand what we're monitoring before we can monitor it. So these last couple of years have been a really big victory in characterizing the sites. And it's exciting that from that foundational work, we're now able to routinely monitor almost 30 of the 45 total wetlands we're monitoring. I listed here the number of projects in each kind of phase over the last year. You'll notice that pre-construction characterization number is kind of low. A lesson from this year is we do reach a capacity with the given staff and time we have for the number of projects we can monitor. On the left-hand side, you see some diagrams of the different types of ways water flow through these wetlands, and we consequently categorize them. Again, this has been detailed in previous documentation and webinars we can share at the end. What I want you to notice about this table is when our researchers go out to these wetlands, almost half of them are now categorized as complex or a mix of hydraulic type. And so this speaks to, we have design plans, ways we can check a box about a category on maybe an application or a proposal. And once these systems are actually built, they're quite dynamic and need boots on the ground researchers to understand some of that complexity. The other thing I like to point out about this table is in our existing portfolio of routinely monitored projects, we have a pretty good representation of these different hydraulic structures. Finally, about 11 of these projects that we routinely monitor have some sort of water level control structure, so they're kind of highly managed ecosystems. And at least 5 have input from external tile drains that pose logistical and conceptual challenges and opportunities to understanding these sites. Early on, our researchers understood that we can't measure everything from every wetland, so they set up what we call a tiered approach, where at a subset of wetlands across Ohio, across the total wetlands we monitor, we will collect more detailed information. You can see these represent a geographic range of different watersheds and different hydrologic structures and restoration approaches. The folks who are leading this program have been committed from the start to interdisciplinary and interinstitution collaboration. I'm really grateful for their logistical and conceptual leadership throughout this time, and I'd like to highlight a few things I've heard them all talk about over the last year. So we've got a group of aquatic scientists who range from folks who know a lot about rivers and stream monitoring to open water, Lake Erie buoy monitoring. And it's been fun to see them all talk to each other. You don't need to know what these words mean. I again just highlight that this is a science-driven program, and we are thinking very intentionally about how we can accurately monitor these wetlands. I'd like to highlight the sampling at different points of the hydrograph as one lesson that we learned last year that we're applying this year. So when we looked at our data from 2022, we started to realize, wow, we had like really good periodic field visits to a lot of these sites, but we're missing certain storm events that might be really important for nutrient function of wetlands. So we very nimbly and concretely made a plan to make sure especially at our focal wetlands, we're capturing those storm events better in 2023. The other element of conversation that continues both with researchers and kind of translating from researchers to managers is how we talk about the limitations of certain approaches, how variable in space these projects are. And as we move into 2024, I'm really excited for the opportunity to better document the assumptions around our estimates, the constraints of our methods, and how we communicate different levels of uncertainty to make sure we're getting information out to the public, but we're doing it in a scientifically credible way. This project would not be possible without the folks on the ground sampling and taking those samples back to the lab and analyzing the nutrients. And perhaps most important from my research coordination perspective, documenting field visits and all the important metadata that's necessary for the long-term success of these data sets. I thank these folks for their continued commitment to our program. Here's what they see on the ground. Many of you have probably been in a wetland and might resonate with these photos. In 2023, we saw this continued reality of an unexpected water dynamics. And maybe that sounds obvious. Wetlands are interfaces of land and water. Of course, the water is going to move differently than a river or a lake, but it does pose logistical and conceptual challenges that we've had to take time to work through. On the top left, you see an example of a sonde or a sensor we deployed that quickly was not deep enough in the water because the water drained faster than we thought. We have folks who have to take samples from kayaks. We've got creative approaches for deploying sensors in these variable water levels. And perhaps most importantly, again, this underscores the importance of multi-year data sets to capture that year-to-year variability. I really like these photos because you can really see the different zones of wetlands. Again, wetlands are not streams, they're not lakes, they're not grasslands. They're sort of a mix of everything. And we have been able to characterize them and document those important characterization notes and attributes in plans that really show how we made our decisions. Finally, I hinted these are wetlands being restored in a highly altered landscape and awfully are more managed than maybe a natural historic wetland would have been. So the importance of capturing tile drains and other water flows through the site emphasizes the importance of having on the ground folks taking samples, noticing new surprises, building relationships with managers for continued long-term success. In addition to our base crews who do the geographic monitoring, we have specialty crews who help us understand the why and the what, or excuse me, the why and the how of the what. So you'll see some examples in the case study of how researchers can estimate nutrient removal by comparing the inflow and outflow of surface water, or how soils processing nutrients. And that information is interesting. It's not necessarily informative until we can tell managers, here's why we think it's happening, and here's how you can build a wetland in the future, or where you can build it for optimized nutrient removal. So we're really grateful for this concurrent data collection of this more specialized data. We don't have time to go into all of the data, but I invite you to stay tuned. Spring of 2024, a lot of these data will be highlighted in our annual report. I'll go quickly to show how drone imagery and vegetation are often connected to see how different patches of vegetation both have pools of nutrients and affect our scaling ability of those nutrient estimates. The hydrology model is really nifty. It can show us how water moves through a particular wetland. and even can have simulations so we can say under these conditions what might happen in the future. That is building off of a lot of data sets, including the hydrogeophysics data, which is sort of the below ground story at these wetlands, and a really impressive set of sensor data that has high resolution data for things like dissolved oxygen and other important physiochemical measurements, weather, and some high resolution water level data. As I breeze through some 2023 kind of by the numbers, I want us all to remind ourselves of our focus on function that Lauren mentioned. Our program is built upon kind of our conceptual understanding of the different ways wetlands can slow down, transform, or retain nutrients on the landscape. We measure water quality and quantity because we know just where wetlands are in the landscape, and their plant structure can kind of buffer the high flow events. We measure plant community and nutrient content to understand these kind of temporary but timely pools of nutrients. So plants will eventually decompose, but again, kind of seasonally, they may play an important role in that nutrient pause or slow down on the landscape. Soil is kind of the real star of the show when it comes to more longer term or permanent transformation and retention of nutrients. So we're very grateful to start building our long-term data sets of soil surface nutrients and have some supplementary process rate measurements. Finally, there's nutrients bound to the soil itself that then accumulates in wetlands. And I grade out sedimentation rates here to let you know that we don't have results from that yet. We haven't measured it yet because we are building this program as we go. We can only do so much in 1 year. I am super excited that I'm pretty sure tomorrow or Friday, we are going to be installing our first sediment markers at one of our sites. So definitely stay tuned. Here's what it looked like when our crews went out in 2023 to measure water quality and quantity. Oh, almost 2,000 samples from almost 50 projects. Again, laying a baseline, really high resolution, spatial and temporal, manual kind of discrete sample data set. A huge victory of this year was our ability to track water level with staff gauges and water level loggers. We always knew we needed to measure both what's in the water and how much there is. This is another example of we don't really know where to put gauges until we know how water is moving through these wetlands. And again, we can only do so much with the number of people we have in 1 year that I was really excited that we quickly got these gauges out into the wetlands because we had that set of part-time and full-time technical staff to get these things deployed. Another victory from this year is starting to share an app-based form for managers to track how they are moving water through a wetland if they have a water level control structure. And I'm excited to kind of expand this even more into 2024. Here's what it looks like when folks go to measure the community and nutrients and plants, well, sample plants to take back to the lab and measure nutrients. And they did this at over 400 quadrats. This is helping us ground truth aerial imagery from the drone and get at that pool of nutrients in the plants. Here's some happy people taking soil samples. Over 600 samples to start that baseline data set for our kind of long-term trajectory of how these wetlands collect soil and nutrients across time, and starting to link that accumulation or those metrics to some biological processes by measuring soil process rates at a subset of wetlands. I highlight here a screenshot of our data collection app to emphasize, again, we are collecting data in a way that the metadata can pretty quickly and accurately be linked to some of the analysis data, and we are reducing error and setting ourselves up for really good, sound, credible, open science. Where is the data? So I want to emphasize, while we've had this program since 2020, 2021, much of it was characterizing wetlands, much of it was building those structures. And those structures include the data workflows that set us up for long-term or short-term success. These are custom-made, kind of designed workflows for the unique data sets and unique combinations of data sets in this program. from left to right, we've got all the different data we collect. Maybe some of you recognize some of these logos for these different platforms that are really important for automatic kind of data check and open science. Number 4, you see data storage is grayed out. And while it's really cool, we can concurrently collect all this data, we can't do everything at the same time. We learned early on that in order to use the resources effectively to set up a database, we need to know what's going in it, what the structure of that data is, that it really didn't make sense to do that before we knew everything else. Another reason we hit pause is we know you're very eager to see some results, and we're eager to share some preliminary summaries with you. So again, these kind of different data sets take a while to learn how to link to, or it takes a while for us to figure out how to link them all together so that we know we're giving you accurate information. But we're very excited that we'll be able to share some preliminary summaries in our upcoming annual report. With that, I'll turn it over to Stephen for a case study of one of our flow-through focal wetlands. Thanks.
All right. Thank you so much, Olivia, for that introduction. And thank you, Lauren, for kind of setting the stage for today. My name is Dr. Stephen Jackman. I'm a professor of biology at Wright State University's Lake Campus. I work primarily on the sunny shores of Grand Lake St. Mary's. And I'm very pleased to be able to share some of the data from the Learn Monitoring Network today with everybody. Very pleased to be able to bring a case study update from the Burntwood Langenkamp Conservation Area. Before I begin, I'd be remiss if I didn't acknowledge that, you know, all the data you're going to see today, I get to be the person that presents it, and I'm very honored and humbled to be that individual. But it's coming from a whole lot of people. Special shout out to Morgan Judy, phenomenal water quality research technician and lab coordinator here at Lake Campus. In addition, Justin Myers and Dr. Sylvia Newell, both part of the Wright State base crew. And in addition to the Wright State folks, you know, there's a whole myriad and sundry of specialty crews that Olivia and Lauren alluded to. And it's really a team effort. It takes a huge number of folks to bring data like this to you all today. So yeah, with that, Burntwood Langenkamp Wetland. It's a wetland in Northwest Ohio. It's located in the Grand Lake St. Mary's watershed. This particular watershed is in Mercer, Auglaize County. It's a couple of 100 square kilometers, maybe about 60,000 acres in size. So it wouldn't be considered a small watershed, but it's certainly not, you know, the western basin of Lake Erie. It's an interesting watershed in that a lot of it is artificial in terms of the kind of history of the lake itself and the watershed itself. The watershed is the product of, you know, a half dozen or so first and second order streams. These are basically creeks, you know, small, medium creeks that flow into a very, very large central basin that is Grand Lake. That central basin was sort of formed from a natural wetland long ago in the 1830s, and it was formed and sort of developed as a source of water volume to supply the Miami-Erie Canal. In the 1830s, the Miami-Erie Canal was the way to ship goods, particularly if you wanted to move them, you know, from the northern part of the state to the southern part of the state or vice versa. There was a whole series of locks and dams that kind of moved up and down the state. And when you get to the top of a watershed, you need a supply of water to keep those, you know, waterways wet, so to speak. And so Grand Lake, you know, and along with Indian Lake and Lake Laramie, these canal lakes served as that. And so as a result of that, it's a very large lake, but it's not very deep. It's got a huge potential for nutrient loading. And over the last, 100, 150 years, that's what we've seen. We've seen nutrient loading come in from the watershed. The watershed's primarily row crop and livestock-based agriculture. And all of that nutrient loading, all of that nutrient runoff over the years, it hasn't been any 1 year or any 2 years, right? It's been a long standing sort of history. All of that has kind of coalesced into and massive water quality issues. So much so that Grand Lake has become one of those places that is kind of a focal point for understanding nutrient runoff, and in the present for understanding conservation methods, and how we can beat back on nutrient loading, and how we can improve the water quality of our freshwater resources. Historically, these streams moving into Grand Lake, they ranked among the highest in the United States in terms of nutrient concentrations. These nutrient loads coming into the lake put Grand Lake on the map in terms of harmful algal blooms and algal toxins. At one point, Grand Lake ranked in the 99th percentile for harmful algal bloom toxins, specifically microcystin. That's the total opposite end of the spectrum that you'd want to be at. And all of this stuff sort of continues to build. And then in the early 2000s, there's kind of a tipping point that's reached. And the watershed is officially declared by the state of Ohio as distressed in 2011. This distressed designation, this time period of 2011, it sort of serves as a sea change moment for the watershed. And beginning about that time, there's a litany of conservation practices that are put into the watershed. And these conservation practices, I mean, there's too many to list, in a webinar setting like this, but I mean, everything from cover crops to manure storage structures to nutrient management planning to manure application timelines. A big hats off to the great producers in the Grand Lake region for really owning these conservation metrics on the watershed. But one of the conservation things that began to happen right about that period of time is there began to be a concerted effort to restore natural habitats. And when you look at natural habitats, it becomes necessary to kind of ask yourself, what is natural, right? What isn't here that maybe should be here? And when you think about Northwest Ohio, you're thinking about wetlands. In the 1700s, pre-European era, I mean, we had huge natural wetland resources, the Great Black Swamp, just to name one of the big ones. And Ohio has lost quite a bit of that. Specific to Grand Lake, it's estimated that Grand Lake was about a third wetland. 1/3 of the total land area of Grand Lake watershed was wetland. That number dropped to less than 0.5% by the early 2000s. And again, it's no surprise that's concurrent with water quality issues. But beginning in that 2011-2012 period and continuing on through today, outstanding restoration efforts have brought back, 1,000+ acres and counting of natural wetland habitat to the watershed. This brings the watershed all the way back up to 2+% total wetland area. And again, emphasis on in counting. It's great to see these improvements. The data that I get to share with you today focuses on one particular restored wetland in the watershed, and that is the Burntwood Langenkamp project. This lies at the intersection of two of those creeks I was speaking of, Coldwater and Burntwood Creek. It was a row crop field for 50, 60+ years. The site sits on about 90 acres. Depending on where the water levels are at, this could be up to 45 wetland acres, 35 prairie acres, and 10 acres of restored forest. The wetland itself, it receives water from Burntwood Creek, which, if you look at the watershed area of Burntwood Creek, you're looking at about 5,700 watershed acres. The wetland itself, those 45 acres, they can hold between 5 and 20 million gallons of water, depending on a variety of factors. This particular site was, as I said, operating as a row crop site for a number of years. And then in 2019, 2020, through the collaboration with the Clean Ohio program, as well as with the great folks in the Langenkamp family, the site was purchased, again, through Clean Ohio and then collaboration with the Langenkamp family. The site was purchased and put into a sort of restoration mindset. And in 2022, The wetland was designed and constructed, and that was made possible through collaborations with lots of different folks, especially through the Mercer County Community and Economic Development Office, especially Teresa Dirksen here in Mercer County. But lots of other folks involved there, as you can see. And beginning in 2023, this year, the wetland's in its first year and begins its sort of annual operation phase. The way the site sort of works, if you want to think about it like that, so if you look in the bottom right corner of the picture down here, you can see Burntwood Creek. That's the inflow for the wetland itself. The idea is to receive water from Burntwood Creek, send it through a wetland before it's able to kind of go on its way. The water from Burntwood Creek can move in through an inflow notch at high water levels. The water level or the water from Burntwood Creek can also be mechanically pumped in with a pump that can move about 500 or so gallons a minute. The water begins its journey in a deep water settling pool. The idea being that you can slow the kinetic energy of the water down and you can drop out heavy particles of sediment, allowing more of the dissolved things to kind of pass through the wetland and be processed along the way. As the water moves, you can follow the sort of dotted line there. The water moves through a mile plus of meandering marsh. This is a shallow marsh area, and it's vegetated out with all sorts of great flag and cattails and various rushes and sedges. A marvelous thing to be able to see. And as the water sort of traverses through that, the idea is that it's being processed, it's being cleaned, and then ultimately it exits out the outflow and moves on down the line cleaner than it was, moves on down the line to Grand Lake. We visit the site every week throughout the entire year. Doesn't matter if it's winter, spring, summer, fall, we're out there once a week taking water samples. We also track water volume and flow with a series of AV sensors and hobo depth loggers. We also track sediment changes once a year. Our vegetation teams come out once a year and they track vegetation. We also have some groundwater wells that we assess the potential for groundwater movement to influence the site. And again, all of these things are done throughout the year. As we look at some of the literal monitoring data and we drill down into that, you can see in the graphic there, and I would encourage you to visit the Learn website. Maybe we can get a link up in the chat box for everybody to see. But the case study printout that's being rolled out, it's either rolled out right now or it's being rolled out later today or this week. You'll see some more up close views of this graphic. But what we're really looking at here is the quantity of water in Burntwood Creek compared to the quantity of water that went through the wetland. Okay, so how much water was in Burntwood Creek? How much water went through the wetland? So when we look at this, we can see that, as expected, Burntwood Creek is not accepting every single drop of water that's in the creek. The wetland's not accepting every single drop, but it is getting a fair amount. All told, just for 2023, this particular wetland was able to capture about 65 plus million gallons of water. About 65 plus million gallons of water. And this is a combination of the inflow pump as well as water coming over the inflow notch. That 65 million gallons, that represents about 4+% of the total annual water volume flowing through the creek for the year 2023. And if we're thinking about this and we're thinking, 63, 65 million, like what's the deal there? Is that a big number? Is that a small number? It's certainly more than a million, but it's not a billion. So like, where are we at? Just to put things in perspective, this particular wetland site sits on 0.75% of the watershed area. It sits on 0.75% of the watershed area, and yet it was able to process between 4 and 5% of the total water volume. This is a reasonable comparison, and this is a good thing, right? But once the water gets in there, what happens to it, right? Doesn't do us any good from a water quality metric if it makes things worse or doesn't affect anything. Fortunately, even in its first year of operation, we're seeing some changes. We're seeing some great changes. Soluble phosphorus, we're seeing yearly overall reductions on average of about 75% from a concentration standpoint. Total phosphorus, and this one is a mixture of soluble phosphorus and the phosphorus that's bound to sediment and particles. We're seeing an average of about 14% over the course of the first year. This number, we're expecting this to get a lot better as the wetland matures and grows up and we get more filtering capacity. We expect this number to go up, but all told, in our first year out of the gate, this is doing pretty well. You can see in these graphics the creek versus the wetland broken up by season. And again, I would encourage everyone to download the fact sheet from Ohio Sea Grant to look into things in a little bit more detail. If we look at some of our other nutrients, moving on from phosphorus, we can move on to something like nitrogen. You can see NOx here on the left. That's just dissolved, one of the types of dissolved nitrogen. And then on the right is total nitrogen. That's, nitrates, nitrites, ammonias, ureas. This is all the nitrogens. And we're seeing great impact as a result of the wetland here, great positive impact. Those total nitrogen concentrations, they're coming down by an average of 70%, 69, 70%. The greatest effect happening in the winter. We're seeing the dissolved nitrogen, some seasonal effect, but we're seeing, 90% reductions there. I mean, these are really good news. This means that the water that comes in is 90% better from a nitrogen perspective, or 70% better from a total nitrogen perspective. These are great improvements. When you take those improvements and you sort of say, okay, we're interested in load reduction. So, what is load? Load is simply quantity of water times the concentration, right? So a great wetland is going to process a ton of water and remove a great percentage of the nutrients. If you remove 99% of the phosphorus, but you only process a gallon of water, that's not going to result in a big load reduction. That might be exciting, but it's not necessarily going to move the needle on a load reduction standpoint. Remember, we're seeing great concentration reductions here, and we're also seeing that on, 65 or so million gallons. We put those together, and again, we're talking about load. How many pounds, how many kilograms did we take out? Total phosphorus, about 15 kilograms. That's about 30 or 33 pounds. Total nitrogen, about 2,700 kilograms. That's about 6,000 or so pounds. These are good numbers. These are wonderful numbers for a wetland like this in only its first year. To equate those on a different scale, you're looking at 30 pounds of phosphorus. What's that look like? 6,000 pounds of nitrogen. What's that look like? Well, 30 pounds of phosphorus, if that was a dog, it would look like that. 6,000 pounds of nitrogen, if that was a hippopotamus, it would look like that. That's about how much these things weigh. That's about what this wetland removed, again, in just its first year. Just its first year, took that out. And these nutrients go into a variety of different reservoirs. They go into a variety of different places. Some of the nitrogen gets denitrified, moves up into the atmosphere. Majority of our breathable air is nitrogen. Some of it binds to the sediment. Some of the phosphorus binds to the sediment. Some of it gets locked up in biomass, in plant biomass. Some of it gets bound to sediment particles. And this is one of the most important take-home messages of the Learn Monitoring Network. We're a whole lot of scientists, and we are monitoring water, soil, vegetation. These are the things that make a wetland: water, soil, and veg. That's what we're monitoring. That's what we're seeking to sort of understand, these fluxes of nutrients, and understand just how much these wetlands can or can't move the needle in our continued sort of, battle against eutrophication in the state. This graphic shows you a little bit about where some of the phosphorus is going. This is a soil P retention statistic. This is called soil phosphorus absorption capacity. This is a calculation that's done using a combination of soil phosphorus levels, soil aluminum levels, and soil iron levels. The reason that we focus on those two metals is iron and aluminum are really, really good at binding phosphorus. They've got great affinity for phosphorus. They do it really well. The more aluminum and iron you have in a sediment, the more phosphorus it's able to bind. So you can put these three statistics, or put these three metrics into a statistic, and you can get a sense of whether that wetland is holding on to things really well, or whether it's likely to sort of spit things out. so to speak. Negative values mean that that wetland's likely to be a source of nutrients. Positive values means that wetland is likely to be a sink of nutrients. We only have about a year of the sediment data right now. Okay, so we have, before the wetland began and then after the wetland began. So there's not really a way to draw a line and project and say, in 5 years, we're going to be here, right? But what this data is showing you is that the post-restoration soils at Burntwood Creek, they've got the capacity to absorb phosphate. And this is a good thing because we need all the capacity and all of the help that we can get. This is a long-term monitoring site. Moving forward, there'll be weekly samples. There'll be groundwater. There'll be vegetation. There'll be soil. There'll be nutrient chemistry. There'll be lots and lots of ways to contribute. There'll be lots and lots of presentations to come and lots of data summaries to come. And so I really, I appreciate everybody's time today listening to this, and I appreciate everybody being actively involved. This is a problem that's not just Ohio. This is a global problem, and we move forward together. And programs like this help us inform strategies to do just that. So again, I thank everybody for their time, and I'm going to turn the mic back over to Chris. So,
Thanks so
Wow,
much,
thank
Stephen.
you. Yeah, that was great. Thank you, Olivia. Thank you, Stephen. This is fantastic. So I'm going to roll through the Q&A. I also want to let folks know some of these are going to come, the questions I'm going to ask are going to come from those that were submitted ahead of time. But I would encourage people, if you look at the meeting down at the bottom, the Q&A, if you ask the question in there, it has been answered. So every question that came in the QA has been already answered by the team. Ed, there was one that was asked by you that I put in the dismiss column because it was asking more questions about alum treatment and chemicals in Grand Lake St. Mary's itself. Recall, these wetlands are upstream of the lake proper. And so the work that this team has done really is not in that space that is Grand Lake St. Mary's. It's more in the wetlands. So I hate the word dismissed. I didn't mean to have that be a negative, but that's why I moved it into that section. Please also look at the chat. There was a website in there that will give you access to previous webinars and outreach materials. So the first one that I'm going to come to from the questions that were submitted ahead of time that weren't already answered in real time is actually, Janice, I think it'll perhaps come to you, Janice Kearns with the ODNR, but maybe Lauren, how might the results of the wetland monitoring inform policy changes to the H2Ohio program? So maybe Janice first, and then Lauren, if you feel like you want to weigh in. Janice, coming to you.
Yeah, sure. Thank you, Chris. Yeah, as Lauren stated at the beginning, I think that there are two primary, goals of the monitoring program. And the first of which is to focus on, is this a cost-effective way to help us reduce nutrients within our watershed with the overarching goal of reducing harmful algal blooms in Lake Erie or associated water bodies? And then the primary questions that I think that I often hear from our ODNR managers is what kind of information we want to get from the monitoring program is, where do we best place wetland restoration sites, and then how should they then be constructed, and then how should they best be maintained? And so those are the suite of questions that we're hoping to get from this monitoring program and the associated research that spins off from it.
Thanks, Janice. And I'll just add as the research lead that even though we're an independent monitoring program run by scientists, we interact really regularly with Janice and others at the ODNR, Eric Sauce, who directs the H2Ohio program through the ODNR, many ODNR managers and many conservation partners through designing and implementing our monitoring on the ground. And it's this sort of frequent formal and informal interactions that also inform some of the decisions that the ODNR is making on the fly, like as the program continues to be implemented.
Yeah, Lauren, sorry about that. I forgot that you had some follow-up slides to Stephen, so thank you for hopping in with this last slide. This is fantastic. Sorry to rush you through that. Coming back to some of the other questions here. What information do landowners and managers want to hear about most? So what have we been hearing from our stakeholders? So anyone on the call, what Olivia, Lauren, what kind of information have you been hearing for the landowners and managers?
I would say the question we get emailed the most is where is the data? And the question we get asked the most when we're talking in the field, and I've heard from technical staff members, is my wetland working, or how long do I have to leave the water in the wetland for it to do the job? Or some of the ODNR managers ask really thoughtful questions about the trade-offs and different benefits of wetlands. So if we're managing for waterfowl, how does that affect nutrient function? Would be some examples, I guess, I've heard over the last year and a half.
Thank you for that, Olivia. Lauren's nodding. Janice, great. There's a question that came in, and you're seeing it in the Q&A now. Can you estimate the lifespan of your inflow pond regarding quantity of sediment captured? How long before maintenance and dredging might be needed? So calling it a inflow pond, but either pond or any of our wetlands. Can we talk about sediment captured, how long before maintenance?
So I can answer that at a large scale. We haven't crunched those specific numbers yet for specific ponds in wetlands. It's possible that some of the designers, especially projects that were designed through firms that specialized in a more of an environmental engineering approach to wetland restoration, may have some of those estimates. We are starting to implement protocols for directly measuring sediment accretion rates, not only to estimate just the physical accumulation of material, but also the amount of phosphorus that's stored on that material. So in the next year or so, we'll start having estimates for a couple of the projects. And once we've kind of developed our best practice for doing that across a lot of different kinds of wetlands, we'll implement that more broadly across the network of projects that we monitor.
Thank you for that, Lauren.
Mm-hmm.
Coming on to another one coming in regarding the soil absorption capacity. Was the wetland soil imported? Was it amended with alum? How did the decrease without flushing downstream? How did this decrease without flushing the P downstream? Any ability, Stephen, in that space?
Yeah, absolutely. No, there was no soil that was brought in. The way that the land was worked was, a lot of soil was moved off-site to supplement other projects that were happening in the region, and a lot of the soil was kept on-site to build up berms and build up, certain areas around the actual wetland.
Thank you, Stephen. There was an earlier question too that was asked by pre-registrants. Is monitoring looking at both DRP and TP? I'm assuming this is coming up because we know both of these are important, but we've also seen the total maximum daily load for the Maumee River. And so just, yes. I know it was addressed a little bit in this presentation, but can you talk about DRP and TP?
The answer is yes. In every water sample we collect, we measure both DRP and TP. We also measure total nitrogen, nitrate, and ammonium concentrations. And in some of the water samples, we measure some other things like urea. Sometimes we also measure conductivity, just the total ion load, which is an index of the general chemistry of the water. We also measure different forms of phosphorus in soil, including the Mehlich-3 extraction and the soil phosphate storage capacity. And we're measuring phosphorus stored in plant biomass. So we're measuring P in all of the places and in many forms to really get at different mechanisms of phosphorus retention and removal.
Thank you for that. Ed, coming back to your question about Grand Lake St. Mary's, Sylvia Newell, who is the director of Michigan Sea Grant, just wanted me to make mention that there is a paper coming out of Cambridge evaluating the alum treats in Grand Lake St. Mary's. So maybe if you want to reach out to Stephen, he can get you access to that publication. Ed, after that, you also asked, based on the BL drainage area impacted by the wetlands and with the data in hand, can one calculate the pounds TP removed per acre and the wetlands cost per pound removed? I know you did your medium-sized dog and your hippo, but can you then expand it to, the per acreage removal rate?
Yeah, you can absolutely do that. You simply just take the amount that was removed and divide that by whatever acreage estimate you want. You could do that by the whole watershed if you wanted to. You could do that by, the wetland. You can parse the data. However, I would be cautious about assigning cost benefit analysis ratios at this moment, though, given that it's kind of the first year. Those analyses are most powerful when you have, wetlands are dynamic systems. They never reach a steady state, but a more mature system, that's probably a better metric to calculate from that.
Yeah, zooming back out across all the projects, the estimate you just saw for Burntwood is a great early estimate. It's based on about 1 year of data. So like Stephen said, continuing to monitor over many years. And across all of these different kinds of projects, our end goal is to get some estimate of pounds removed per acre so that we can do some of those cost benefit analyses. The issue is for all of these different kinds of wetlands, it takes different kinds of monitoring, different approaches to get to that final number, and then different kinds of assumptions. And so the next thing we're really going to be tackling, like literally at our meeting in January, is looking at several different kinds of projects and figuring out what level of estimation is acceptable, how much direct data do we need to feel confident in that nutrient removal per acre value to make decisions based on it. Because we could give you a pounds removed per acre for any of these sites right now, right? Some of them we have no data, but we could give you an estimate. So a big focus of ours is not just to calculate this number, but figure out how much certainty can we give that number and how much certainty is needed for different kinds of decisions. And that's where this two-way interaction between us as the researchers calculating the numbers and the partners making the decisions is really important. And some of our ability to do that, thank you for whoever put this slide up, is being augmented by this growing network of projects. We have our initial ODNR and Ohio Water Development Authority Wetland Monitoring Program that we're telling you about today. But because of the foundation that that program has built, we've also gotten support from the U.S. Environmental Protection Agency, from the Ohio Department of Higher Education, from the USDA, NRCS, to support lots of coordinating and related and integrated projects that really enhance our ability to answer lots of different kinds of questions and collect lots of different data about these projects.
Thank you for that, Lauren. It's always about leveraging and partnerships. And yes, it's not just the H2Ohio funding, although critically important, that has been able to leverage other funding sources. I will ask, there was a question that came in regarding to and maybe Haisa or multiple people could answer this question, but it's really asking about various hydroclimatic and water quality sensor networks that are out there. So can people, I think, just want a glimpse into like what kind of machinery and equipment and sensors are out there?
What an excellent question. We have lots of different kinds of sensors that have been deployed. Our ability to deploy sensor networks has been greatly augmented by the US EPA Great Lakes Restoration Initiative program by additional support that we got from them. We have an excellent sensor specialist at the University of Toledo, Zach Swan, and all of our sensor systems are as integrated as possible. We're collecting data on, in at least the focal projects, we have weather stations. We have sensors collecting water level and flow where it's relevant. So our main goals there are to be able to build water budgets in focal projects and fully account for all of the water entering and exiting, both from the surface and in the subsurface. And in our non-focal projects, the ones where we don't have as much resources to fully invest in all of the measurements that we can, we're putting in water level sensors just to surveil how the wetland is connected to the landscape and the frequency and extent of inundation that those wetlands experience. Because if a wetland isn't getting water from the landscape, it can't do much to remove the nutrients from the landscape. We also have water quality sensors deployed, measuring things like dissolved oxygen and pH and conductivity, and importantly, turbidity, which we're trying to see how good of a proxy for total phosphorus loads and load reduction that is. And our excellent data managers, Haisa Mendonça and Ishfaq Rahman, are building out infrastructure that's going to automate as much of the quality control of those data streams as possible so that we can eventually publish them live. At the moment, those data streams are not being shared live and with the public, but in the future they will be. Haisa or Ishfaq, I think Haisa is a host on the panel. Is there any other important nugget to share about the sensor network and the data that it's producing?
No, I think you covered it all. Yeah, we're in the process of just developing our quality control workflows, and then once that data is just quality assessed and quality checked, and we know we're putting pretty robust data out there that have all the metadata that anybody might need to understand it, that data will be publicly available, likely through our GitHub page. H2Ohio Wetland Monitoring Program has a GitHub page that we've been building as we go, Ishfaq and myself, and yeah, so this coming year should likely have you'll likely see a couple documentation coming out about our workflows and some data sets starting to be released.
Thank you for that. We're at 1 o'clock, actually 1 minute over. I just wanted to, with the instrumentation, this is a great example of public-private partnerships too. We have groups like Limnotech and Freeboard and the Cleveland Water Alliance that are really making these sensors talk to each other and informing sensor development and deployment. So there's some great public-private partnerships here too. I wish we could get to all the questions that came in prior to registration. I think we got to most. Please see that the questions that were submitted through the Q&A, many of them were answered. And I hope this was exactly what everybody needed to hear and see. I know there was a question in here about how to engage with this partnership and get involved and learn about the research and that. Please reach out to the Learn team members. Olivia could be one of those contacts. But thank you for your time. And Lauren, I'll turn it back to you if you had any parting words, or Janice.
Thanks a bunch, Chris. I just wanted to give a plug. There's a QR code now. Please check out the Learn website for more information. We've published our 2022 annual report, and stay tuned for our 2023 annual report. Will be our first release of preliminary data to the public. We're really excited about that. Thank you all so much for your interest. We will do our best to follow up with questions, and don't hesitate to contact us if you have any questions that remain unanswered.
Great. Thank you, Lauren. Thank you, Olivia and Stephen, for the presentation. And thanks to the governor and the H2Ohio program and the DNR for all the support. This has been phenomenal. Thank you, everybody. Have a great, I think it's Tuesday.
Yeah, that's all right.
There we go. Take care, everyone.